we can determine the probability mathematically, but not exactly what his best fortune is. So let's look at writing functions to do this with a Monte Carlo experiment. And it's the same approach that we use with any sort of Monte Carlo experiment. We just simulate the random process once, and then we repeat it as many times as we need and compute whatever statistics, the mean or the relative proportion or the variance or the number of times that it's on one side of the distribution or the other side of the distribution. You can extract all of these statistics readily. And you use this collection of statistics to approximate the probabilities to answer the questions. So we had 3 questions. We wanted to know, let's look at the last one first, the best fortune. The second one, the likely number of tosses. That another way of saying that is how often will he be in the lead. So we'll approximate the variable we'll use to answer 3 will be F. We'll use L for lead to represent number 2, and then we'll have another one for the probability of him breaking even. So let's first look at the fortune F at the end of the game. And we'll write a function to do this for one game. We've already executed lines of code that do it, but we'll roll these up into a function so we can call this function remotely whenever we want to. So here is the function for one game. Now, note a couple of things about this, and we did not talk about this at any length. It's very easy to write a function in R, and a user-defined function, which is what this is, has several well-defined elements. It always has the keyword function. Whenever you see this, R knows, or when the interpreter sees this, R knows that you're creating a function, writing a function. We could create this as a named function or an unnamed function, and what I mean by that is if I did not use an assignment statement, if I just did this and loaded it into memory, it would still create the function for an instant, but it would not have any mechanism to call it. It would be unnamed. And you may say, well, why would you ever want to do that? Well, there are cases where you want to do that, where you want an unnamed or anonymous function to be called in the middle of an expression. But more likely, you want to create a function with a name so that you can always fetch it. You can always call it no matter where you are. And the way you do that is just simply you give it a name, any name you want, and you use an assignment operator. An equal sign is an assignment operator as well. So, okay, so the function keyword, that's the first part, the first critical element of a user-defined function. The second critical element is the argument list. Even if there aren't any arguments, you must include the parentheses. But you can you include in the parentheses any arguments, any variables that need to be passed into the function in order for the body of the function, the commands in the body of the function to operate. You can have any number of them that you want, any number of formal arguments, and this is called the formal argument list, any number of formal arguments separated by commas, and in each formal argument it consists of 2 parts. You must have a name, but you can also give it a default value. So this function would also work if I created it like this. If I just said function n, this would work every time you called it, but you would have to include a value for that argument for n. Otherwise, you get an error. You get a mismatch in the number of arguments. But if you write the function with a default value, even if the person forgets to include that argument, it'll still run. So generally speaking, it's better, if you're writing a function, it's better to give default values to all of the arguments if you know what they should be, if there's a sensible way to do that. It makes it easier for the user to call the function. They don't have to figure out what all these arguments are. So again, formal argument list must include the name, if there is one, and optionally you can include a default value, which frees up the user from calling it, as we've done here. Then follow that, that's the second critical element of a function. Following that, you have the body of the function, which is circumscribed by the blocks, brackets. So these are block statements. This is common to many programming languages, where the body is what the function actually does. It executes each statement generally on its own line in the body, line at a time, from top to bottom. So here's the beginning of the block. In RStudio, it automatically keeps track of the end, which is kind of handy. If you only have one statement in the body, you're just adding two numbers together, you don't even have to use this. But if you have more than one statement in the body, more than one expression, this is one statement, you need to use the brackets to separate them and put each statement on a different line. Okay, so when this function is called, it passes n in as 50 unless the person stipulates a different number for n, and it does exactly what we've been doing all along. It samples from this win and loss possibility, puts that in win, and sums it. Okay, so let's do that. So we've created it. So we have the function keyword, formal argument list, the body list.